to show you. Let's just keep going. Okay, let's ask ourselves why. Let's see, why is this happening? This seems so weird. Why? Why is because of our definition of the center of mass, right? It's 1 over m. It's like the mass weighted average position. m1 x1 plus m2 x2 plus blah, 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 blah. You could have a million of them. Right now we just have 2. Dot, dot, dot means more of them. Big M means the total M. I'll put TOT on here so you know what I mean. Lowercase plus lowercase equals uppercase. Okay? So now let's take a derivative with respect to time of this equation. WRT means with respect to in my world. All right? So the derivative, the time derivative of the position of the center mass is the velocity of the center mass. Okay? And we got 1 over m total here. 1 over m total. And then what is this? This is mass 1 times its velocity. Mass 1 times the velocity of 1 plus mass 2 times the velocity of 2 plus blah, blah, blah. Could go on forever. Okay. So all we do is take a derivative. If you take a derivative of a thing with a bunch of extra parts added together, you just take the derivative of each one. The masses are constant, so they don't participate. It's just the derivative of position is velocity. See, we're using these general ideas. Okay, so now we're going to bring this over here. That's all we're going to do. And we're going to say the mass total, TOT, sorry. That's just crap. Times the velocity of the center of mass equals, what we could write actually is P1 plus P2 plus blah, blah, blah. Because M times V is P. Or well, I should have written it with M's and V's, because this looks like the collision formula. It just looks just like our, perfectly inelastic collision. But it's not just true for the perfectly inelastic collision. This is true in general. So this was just sort of to get it in your head. This whole exercise makes you say, okay, center mass just happens to have this mathematical property that makes it match all these ideas. But in general, it's true. So in general, when physicists say in general, they mean it's always true. All right? Except for special cases on your homework. But in general means this is always true. An isolated system has total momentum of a point mass, right, as though it were a point mass, m total at COM, or at VCOM, at the velocity of the center mass. So that's just the general idea.